Well, welcome back to our review on trigonometry. Our focus tonight is on the unit circle and reference angles. So a quick reminder about the unit circle. We should probably highlight this in our notebook here. The unit circle is a circle centered at the origin with a radius of 1. Hence, the unit circle. The equation of the circle is x squared plus y squared equals 1, and here's a diagram below. So things we should label right off the bat are these four main points. So that first point, I went over 1 and up 0. The second point here is 0, 1, negative 1, 0, and then obviously 0, negative 1. Those are our four main points on the unit circle. And again, unit meaning they are all 1 away. Every radius that you could possibly draw in is 1 away. And I want to recall, in a circle, there's an infinite amount of radii. It's not just these four lines here. Basically, any place from the origin to the circle is a radius. You can draw an infinite amount of them in. Okay, and all of these have a length of 1. Every radius you could possibly draw in has a length of 1. All right, in our first example, it says the unit circle below. So the first thing I highlight is the word unit, because that's implying, again, any radius I see has a length of 1. Find an expression for the 6 trigonometric functions in terms of x and y. Now there's something unique about this. Which of these, so when you draw this circle out, and we just saw this on the last practice test we took, some of us couldn't even figure out which one was the radius. And I want to stress again, anytime I go from the center to the circle, that represents a radius. And if I look at this triangle, only one of those sides is clearly a radius. Only one of them goes from the center to the edge of the circle. And right off the bat, I want to slap a 1 on there. That has a length of 1. Now, here's another little bear trap for you that some of us missed. If this is the center and you went to the left, what do you know about this distance here? Hopefully you nailed it. It should be a negative x value. And because I went from this x-axis up, this should be a positive y value. Okay, so the first thing I want to do is label those sides for myself. This is actually negative x, positive y, and this has a radius of 1. So really, this point is actually negative x, comma y. All right, so it said find the 6 trigonometric functions. So let's start with sine of theta. All right, and I'm going to move my theta inside the triangle, of course. And when I think sine, we reviewed, we're going to say SOH, katoa, S-O-H. So I'm going to go to my opposite side, which is y, over my hypotenuse, which is 1. Now I'm going to go get its reciprocal right off the bat, which would be cosecant theta. And all cosecant does is take whatever fraction I wrote for sine and flip it. So that's just 1 over y. So let's go get cosine. So SOH, katoa, A over H, the adjacent side to the hypotenuse. So I'm going to say that's negative x over 1, which of course is just negative x. And I'm going to get its reciprocal, which is secant. So if I take my fraction answer and I flip that, I get negative 1 over x. Now it doesn't matter where that negative goes, we're just saying this fraction is negative. And then lastly, we'll get tangent, which is toa, opposite over adjacent. So my opposite is y, my adjacent is negative x. So y over negative x, and its reciprocal is cotangent. And we'll just flip it. So that's going to be negative x over y. All right, so you're going to want to copy this picture down for yourself for example 2, so pause it and go ahead and do so. So here's the first question. Which line segments have a length of 1? Now, again, they told me it's a unit circle, so any radius, that's what I want to remind myself of. If it's a true radius, it has a length of 1. So basically, you have to start at the origin, at the center of the circle, and you're looking to see who at the center goes out and touches the circle. So from O, obviously you're starting at O, that's the center. From O to what other letter touches the end of the circle? Well, I would say there's 2 of them. Can you find both of them? There should be an obvious one here, O to B, that's a radius because it goes from the center to the edge of the circle. So we can jot that bear down. And I would definitely say there's a second one. Again, from the center to the edge of the circle. Now, clearly it's going to be in quadrant 1 because there's nobody going over here. But from O to C, that is also a radius. Okay, and there's only 2 of them in this picture that we have here. The first thing I want to do is identify sine, cosine, and tangent. So again, when I say sine, I'm saying SOHCAHTOA, opposite over hypotenuse. Now I want to focus on just the triangle in the circle. Okay, so highlight that for yourself. Grab a colored pencil, highlight that for yourself. I'm just focusing on that piece. So if I say opposite, that's this side, which is A to B, over the hypotenuse, which we just said has a length of 1. So the sine value is AB. The cosine value, so A over H. So I'm going my adjacent side, which in this red triangle is just O over A, over the hypotenuse, which is again a length of 1. So that is just OA. And then we'll grab tangent. Tangent is opposite over adjacent. Now, when we think tangent, we want to think a little differently. I want you to think back to geometry. What does a tangent line do? A tangent line actually takes your circle and it touches the circle just once. So I wouldn't say any of this red triangle represents tangent, because a tangent line doesn't sit inside a circle. A tangent line is outside, and again, it touches the circle once. So actually, this line segment, D to C, represents our tangent line. So I guess the whole idea of reviewing this is to remind you that any point on the circle can be represented by sine and cosine. If I go over the x value, notice that's O to A, that represents cosine. And if I go up the y value, that represents sine. So truly, any point on the unit circle, I want you to highlight point B there, any point xy on the circle can actually be represented by cosine theta, sine theta. And we talked about this earlier in the year, and it's very easy to remember because it's alphabetical. Just like x comes before y when you graph a point and go over x up y, c for cosine comes before s for sine, so it's cosine sine. But any x value is cosine and any y value is sine. Alright, so next we want to focus on quadrants of the unit circle. And we had a little saying, we said all students tip cows. And these were the 4 quadrants where things were positive. All was all trig functions. S is obviously sine and its reciprocal cosecant. T tangent and cotangent. C cosine and secant. And obviously you have those written down. Other things you should recall. Every point xy on the unit circle can be represented by cosine theta, sine theta. Now, as you go, it's going to change whether it's positive or negative. Remember, here they're all positive. So this would be positive cosine, positive sine. However, when I move to this quadrant, only sine is positive. So this point would be negative cosine, positive sine. In this quadrant, only tangent's positive. So this would be negative cosine, negative sine. And then, only cosine's positive, so positive cosine, negative sine. Now, tangent has a very unique way to be written, okay? And you have to remember it as a trig ratio. Tangent is equivalent to sine theta divided by cosine theta. Okay, we had quizzes on that throughout the year, but tangent should be sine over cosine. So let's tackle a few easy problems here. If sine is less than 0, obviously I see the less than end first, the small end. So less than 0, meaning sine is negative, and tangent is positive. Which quadrant do I have to land in? So all I do is all students tip cows, and I cross things out to myself. Well, sine is negative, so it can't be where they're all positive or where sine's positive. Now I have 2 choices left, so it's 50-50. Tangent is positive, so out of the 2 that's left, I've got to be in quadrant 3. Try another one here. Cosine, I see the greater than sign, so cosine's positive and cosecant is negative. So I start with my all students tip cows. Cosine is positive, so I can either be where they're all positive or cosine's positive, so I can eliminate those 2. And let's say even forget who that is. If it's negative, where can it not be? In the all positive section. Okay, but obviously cosecant goes with sine, and sine is negative in the 4th quadrant. Alright, maybe a little trickier. Now they tell me sine is actually a negative 1/3. Well, all I'm going to say to myself is that I know sine is negative. I don't actually care what that fraction is, but I do know sine is negative. So all students tip cows. I'm not going to be in the all positive or the sine positive. Now, they're telling me a negative times somebody has to be greater than 0. Well, if it's greater than 0, I know my answer needs to be positive. So a negative times a what gets me a positive? A negative times a positive or a negative times a negative? Clearly a negative times a negative. So I need that cosine value to be negative. So out of the two remaining, remember cosine's positive here, and I need it to be negative, so I'm going to go again with quadrant 3. All right, sketch and label an angle in standard position if theta equals 7 pi over 6. Now, we talked about degrees to radians, radians to degrees last time. Most people think degrees are easier because you can picture this is a 90, 180, 270, 360. A lot of people can't picture 7 pi over 6 right away, and that's fine. So take your 7 pi over 6 and convert it to degrees. So you multiply by what you want. You want degrees, so you want 180 over pi. Pi on top, pi on bottom, cancel. 6 goes into 18 3 times. So that's really 30 times 70 is 210 degrees. So basically you have to sketch 210 degrees. Well, this is 180, 270. I know my 210's there. There's my initial side. I'm going positive, so make sure you draw your rotation in. And I'm going to say theta equals 7 pi over 6. So if they talk to you in radians, talk back to them in radians. Okay, you can convert to degrees to make your life easier, but make sure everything's labeled in radians. Okay, so now they say sine is negative and tangent is positive. What quadrant must this terminal side lie in? So again, I'm going to quickly go all students tip cows. Sine is negative, so I'm going to kill this one and this one. And out of the two remaining, tangent's positive, and I hopefully can narrow that down pretty easy to quadrant 3. All right, moving on to the second half of the review, reference angle. A reference angle, and again, get this in your notebook, is an acute angle. There's the first thing I want to highlight. Acute means your answer has to be less than 90 degrees. An acute angle formed by the terminal side of the triangle and the x-axis. You are only allowed to talk about the x-axis. Angles in the first quadrant are their own reference angles, and then you have the quadrantal angles, which do not have a reference angle. So, example 1 that you have sketched out. In quadrant 1, it's already an acute angle, less than 90, so let's make a note, I am my own reference angle. So my reference angle is 60 degrees, plain and simple. Quadrant 2, okay, so now I want you to sketch 120 degrees. How do you get the reference angle? Well, you can only say how far you are from the x-axis. Now your gut's saying, well, duh, I'm 120 degrees from the x-axis. Now that's true, but it also has to be an acute angle. So in quadrant 2, my reference angle is actually over here. The rule is to take 180 minus the reference angle. And 180 minus 120 gets me a reference angle of 60. Quadrant 3. Okay, I'm going to graph my 240 degrees. That puts me in quadrant 3. So again, I'm still saying, how far am I from the x-axis? Here's that x-axis. So I'm going to do my angle minus 180. So 240 minus 180 gets me 60 degrees. And in quadrant 4, okay, so I graph my 315 and I'm saying how far am I from the x-axis? Now notice I'm not near the 180 mark anymore, right? 180 was on this side of the y-axis. I'm back on this side. So now I'm going to use 360 minus my 315 to get a reference angle of 45. Okay, so again, just a quick review. You have all this in your notes. Go back and look. You can watch the older video if you're still stuck, but a quick review on reference angles. All right, so I'm hoping to fly through this section. Sketch the angle, 127. Okay, so again, 90, 180. I know I'm in the second quadrant. Make sure you draw the initial side and the terminal side, and you show which way you rotated. There's 127 degrees. Part B, state the reference angle. How far are you from the x-axis? Yes, you're 127 degrees, but that's not an acute angle. So we're going to do 180 minus 127. Hopefully you get 53 degrees. And, oh, it says shade in the reference angle. So let me first shade in the reference angle. And then find the reference angle, 53 degrees. All right, 353. Okay, so that's close to 360. So again, initial side, terminal side. Show which way you went, 353. Shade in your reference angle, how far you are from the x-axis, and then let's go get it. So that's 360 minus 353. I'm going to go 7 degrees. 215, same idea. So this is 180, 270. Here's my initial side, my terminal side. 215 degrees. Shade in your reference angle, how far you are from the x-axis. And I'm going to say that's 215 minus 180. Remember, I need a positive acute angle, 35 degrees. 4, bear trap. They put it in terms of pi, so it's in radians. Who cares? Put it in degrees. So I'm going to multiply by 180 over pi. So I do a lot of canceling. I cancel my pi's. Clearly you have a calculator. I'm just going to show you what I do in my head. Let's see. I'm going to say 4 goes into 180. How many times? 4 goes into 16 4 times, and it gives me a leftover of 5, so I'm going to say that's 45, and now I'm going to take my 45 times my 15, and that's going to get me 675. Now clearly that's too big, so that's saying it's going to go around once, and I'm going to take out 360 because it goes around once, and that gives me 315. So I went around once, and then I'm going to go 315, and say how far am I from the x-axis? 45 degrees. Alright, when we talk unit circle, we also have to know our exact values. So I'm just going to fill the table in quickly. Again, this is a review. This is stuff we've quizzed all year and we should know pretty well. The sine of 30 is 1/2, as well as the cosine of 60. So we always said they're across from each other if you write the table this way. The sine of 60 is radical 3 over 2, and so is the cosine of 30. Again, they're across from each other. The 45s of sine and cosine are the same. That's your radical 2 over 2. And then we said the tangent of 30 has all the 3's, so that was radical 3 over 3. Then it loses the denominator for the tangent of 60, and it's just radical 3, and the tangent of 45 is 1. Alright, in the next part, and let's get the directions at the top, we need to find the exact value. And I want to be very clear that when you see those words, that means you are not allowed to use a calculator. So let's put no calculator there. Alright, so these take quite a few steps. So the first thing I say is, where does 210 fall? So I go 0, 90, 180, 270, bam, I know it's in this quadrant. All students tip cows. Notice I'm in tangents quadrant. Is my function tangent? No. That means this answer is 100% negative. Okay, now I need to get my reference angle. We just reviewed reference angles. 210 is how far away from the x-axis? Well, I'm going to do 210 minus 180, and I'm going to get 30. Now, I want you to box this in. This is a value from the table that we just reviewed. The cosine of 30 is radical 3 over 2, but my answer has to be negative because of the quadrant that I'm sitting in. Let's try another one. Ooh, a little sneakier. Cosecant of negative 135. So first things first, let's draw it out. I have to go negative 135, so I'm going to swing backwards. 90, 180. So negative 135 puts me here. Again, all students tip cows. This is tangents quadrant. This is not tangent, which means my answer is negative. So I'm going to have negative cosecant. So now if I went 135 this way, how far am I from the x-axis? How many degrees is that from that x-axis? Well, hopefully you're saying if it ends in a 5, it's obviously 45. So negative cosecant of 45. Now there's one more bear trap here. Cosecant's not somebody you memorized, but it is somebody you know how to flip. So all you have to know is that cosecant is the reciprocal of sine. Okay, so I'm thinking sine of 45 in my head, which is radical 2 over 2. And then I have to say, okay, if I really want cosecant, I have to take that answer and flip it. So I'm going to say it's negative 2 over radical 2. Now, most of us were really good at rationalizing. We typically don't leave a radical in the denominator. So it's negative 2 radical 2 all over 2. Remember, I'm just multiplying the top and bottom by radical 2. Those 2's can cancel. So I would say my final answer is negative radical 2. We'll squeeze one more in here. The cotangent of 4 pi over 3. Now, again, they put it in radians. Yuck. So what? Convert it to degrees. 4 pi over 3. I want degrees, so I want goes on top. 180 over pi. Kill my pi's. 3 goes into 18 6 times, so that's 60 times 4 is 240. So in my head, I'm really graphing 240, which again puts me in the third quadrant. So all students tip cows. Now notice this is tangent's quadrant, and I do have the reciprocal of tangent, which is cotangent. Therefore, my answer is going to remain positive. So my only key now is to figure out what my reference angle is. So I'm going to have the positive cotangent of 240 is how far away from the x-axis? Well, that's 60 away. Okay, now again, I have to think the reciprocal function, the tangent function. What is the tangent of 60? The tangent of 30 has all the 3's, therefore the tangent of 60 is just radical 3. Now cotangent is going to take that radical 3 and flip it upside down. So I'm going to say the cotangent of 60 is 1 over radical 3. And again, we typically rationalize that, so we'll multiply by the radical 3's. So I would say it's radical 3 over 3. Well, that's going to wrap up day 2 of trig review. Our next big trig review is going to be on trigonometric graphing. So we look forward to some great practice, and we're not too far from the end, guys. Looking forward to it. Have a great day.